Hello, this is David Shreeve, Algebra 2 instructor with Florida Virtual School. I've had some questions on finding inverses of exponential and logarithmic functions. So I'm going to do a couple examples. An important thing to remember is that the inverse of an exponential function is a logarithmic function, and vice versa. So the inverse of a logarithmic function is an exponential function. So we'll start here with an exponential function of x equals 2 to the power of x. We're going to find the inverse of that function when x is a value of 32. So to start here, and these steps apply to finding the inverse of any function, a linear function, a quadratic function, any function. But we're going to replace the function notation f of x with y. And then we're going to swap places with the x and y here. So put the x where the y is, and put the y where the x was. Alright. Now this is an exponential equation. The bases are not the same. We cannot make the bases the same. That means we're going to have to take the log of each side. But I'm going to take a specific base log of each side, and I'll show you a little rule here. The log base b of b equals 1. So a log with a base that is the same as the argument will always equal 1. And we're going to use that to get our y isolated here. So think about it, b to the power of 1 equals b. Anything to the power of 1 just equals itself. So I'm going to go ahead and take log base 2 of each side here. So log base 2 of x equals log base 2 of 2 to the power of y. I want to remember our properties of logs here. If there's a value in front of the log, that value goes up here in the position of the exponent. And we're going to use that property, but we're moving backwards here. So this is how we're going to isolate that y. We're going to move that y in front of the log. So we've got log base 2 of x equals y times log base 2 of 2. And remember, log base 2 of 2, this actually equals 1. So at this point I've isolated my y, because 1 times y is y. So y equals log base 2 of x, but they want us to solve when x has the value of 32. So log base 2 of 32. And to simplify this value on the right, we're just going to use change of base formula and a calculator. So we're just calculating log 32 divided by log 2. And if you, I'll show you how to do that on if you have a TI-83, TI-84 series. I'm just going to do log 32 close parenthesis divided by log 2 close parenthesis, and we get 5. So if we want to use the correct notation here, we'll just say the inverse of the function when x is a value of 32 equals 5. Alright, so now let's do the other type, which is we're going to go from a logarithmic function and we're going to convert that. We're going to find the inverse of that, which will give us an exponential. So here's the example. F of x equals log base 3 of quantity x plus 4. We're going to find the inverse when x is a value of 3. So to start, we're going to find the inverse, same steps as before. Change my function notation f of x to y. And then I'm going to swap places. The x and y are going to switch here. So this time we're going to, again, the step here is to, after we complete those first steps I went through, we just solve for y. Alright. So to get the y by itself here, we're going to change to exponential form. So remember, we take the base here, which is 3, to the power of the value on the other side of our equal sign, and that's going to equal my argument. When I change to exponential, that's going to get rid of my log. So we've got 3 to the power of x equals y plus 4. Remember, we still need to get our y isolated here, so I'm going to subtract 4 from each side. And we're going to end up with y equals 3 to the power of x minus 4. And it's important to note that the minus 4 is not part of the exponent. Of course, that's what we call a constant, so that's at the end there. And if you want to, same thing as we did over here, I mean, you could technically change your notation from y back to the notation indicating the inverse of our f of x function if you want. And they want us to simplify with an x value of 3, so we're just going to plug in a 3 for the x. 3 cubed is 27, and 27 minus 4 is 23. So that would be our final answer there. All right, I hope this is helpful.